All right, so here we're going to be factoring the sum and difference of perfect cubes. So first of all, familiarize yourself with perfect cubes. Now you know a lot about perfect squares, right? Like 1 squared is 1, 2 squared is 4, 3 squared is 9. Like those you kind of have memorized because you use them a lot. Like when somebody asks you the square root of 81, you're like, oh, it's 9 because 9 times 9 is 81. But cubes you don't know as much, but they do the same thing. So 1 to the third, 1 times 1 times 1 is 1. 2 to the third, 2 times 2 times 2 is 8. 3 to the third is 27. 4 to the third is 4 times 4 times 4 is 64. 5 to the third, 5 times 5 times 5 is 125. So these answers, these 5 problems that we've just done so far, like those should be pretty recognizable. Then you start getting to like higher ones, and then maybe you don't know those as much, but I mean, these first 5 should be recognizable, right? All right, so 6 times 6 times 6 is 216. 7 to the third is 343. I start to not know these either. 8 times 8 times 8 is 512. And 9 times 9 times 9, like 729, I think. Yeah. And 10 to the third, 10 times 10 times 10 is 1,000. So these are just things to recognize. You know, you can always go to your calculator, and if you think something's a perfect cube, what you can do is you can check it out in your calculator, and you can say, let me check if that's a perfect cube by doing its cube root. So you go to the math button, if you go down to the cube root, and just type in, you know, the number that you want to check. If it comes out perfectly, you're like, oh, okay, it is a perfect cube. If you check it, like let's say you're trying to check the cube root of like 90, and you're like, oh, maybe that's a perfect cube. No, it's not, because it's a decimal there. Okay. All right. So next thing we have to do here to understand what we're about to do to factor these is let's multiply out an expression like this. Now this problem is built in a special way. Excuse me. I got 2x and I have 5. If you take 2x and you square it, so if you take 2x and you square it, you get 4x squared. So that's my first term over here on the second part, on this trinomial. All right, if you multiply 2x times 5, 2x times 5 is 10x. So ignore that negative there for now, but that's 10x. And if you take 5, this number here on the end, and square it, you get 25. So there's a pattern to this creation here, to this problem here. These pieces right here are created from these numbers there in a special way, which we'll talk about in a minute. And my signs, well, just for now, you see my signs here. All right, so let's work this out. So 2x times 4x squared, I got 8x to the third. 2x times negative 10x, negative 20x. 2x times 25 plus 50x. Here I got plus 20x squared. Oops, I made a mistake. 2x times 10x was 20x squared. Sorry. Then 5 times negative 10x is negative 50x. And then 5 times 25 is plus 125. So look what happens here. Negative 20x squared, positive 20x squared, 50x minus 50x. Everything has like fallen in on itself. So my answer is 8x to the third plus 125. My answer is the sum, it's the addition of 2 perfect cubes. 8 is a perfect cube and 125 is a perfect cube. And then obviously x to the third is a cube. Okay. All right, so what we're seeing happening in the last example can help us know how to factor the sum, meaning the addition, or the difference, meaning the subtraction of 2 cubes. All right, so what we're going to do when we have 2 cubes, when I have a cube here and a cube here with a plus or minus in the middle, doesn't matter. You know, with perfect squares, you can only do it with a minus. So like if you had 9x squared minus 25, remember, that's the only one that you could factor. You'd get 3x plus 5 and 3x minus 5. You can't do it. If this was plus, then you couldn't do the factoring, right? But with cubes, it works for both. So what you're going to do is you're going to take these pieces and do this, okay? So you're going to look at this piece and you're going to think, what makes 8? 2 times 2 times 2. So you're going to put a 2x here. And you're going to look at 125 and you're going to like, 5 times 5 times 5. So you're going to put a 5 here. So that's how we're getting this piece right there. Then you're going to do what I have over here. Square, multiply, square. You're going to take 2x and square it. So that's 4x squared. You're going to take 2x and 5 and multiply them together. So 10x. Then you're going to take the 5 and you're going to square it, 25. So do you see how I'm getting all these pieces back here? All right. So that's what that part means. And then we're going to do this. We're going to do the word soap. Soap means same, opposite, always positive. So I'm going to take the sign that was here. I'm going to put the same one. I'm going to put the opposite and then always positive. And so you see that's how I have that. All right, so let's just jot down what that means. That means same, opposite, and always positive. All right, so we're going to factor the set of perfect cubes. So I got a little part, big part, so a binomial and a trinomial. Think about 27. 27 was 3 times 3 times 3, so I'm going to put 3x. 64 was 4 times 4 times 4, so 4. And again, we'd also want to check, 27 and 64 don't have a GCF, so we would check that first, but this one's a simple one. All right, so now it's time for square, multiply, square. So I square the 3x, that would be 9x squared. Then I multiply 3x and 4 together, so that's 12x. Notice I don't have any signs in here yet. Then I square the 4, 16. So now you come through and you put your signs in. You do same, so plus stays plus, opposite, always positive. And you're factored. Now, one important thing to note, this looks like it might factor again, but if you try, you will not be able to do it. It never factors anymore. This has imaginary solutions. You would need the quadratic formula to factor it, but you're finished. This is all you can do. Okay, so if you want to, this is basically like the formulas for it, but it's easier kind of to remember like a little pattern like we have than memorizing these formulas, but you can see, square, multiply, square, same, opposite, always positive, you can see those things there. All right, so here we go. So x to the third minus 125. So nothing can come out of it. So I got binomial, trinomial. X is x to the third. 125 is 5. I square the x, multiply together, and square the 5. Then same, opposite, always positive. Done. All right, over here. Now, I tend to not like my x term in the back. And this is addition, so I could leave it like this, or I can switch it around. So I'm going to switch it around. All right, so I can do that with addition. I can switch it if I don't like it. You could have left it. It's not going to matter. It's still correct. So nothing comes out, no GCF. So 64 is 4 with an x. 125 is 5. Square the 4x. Multiply together. Square the 5. Same, opposite, always positive. All right, now on letter C. Again, this looks backwards to me, but if it's subtraction, too bad. You just have to deal with it. It's not, if you want to turn this around, you'd have to put a negative in front of the whole thing, like a negative, and then 8x to the third minus 343, and that starts to look pretty ugly. So I don't want to do that. So we're just going to leave it backwards looking. All right, so 343 comes from 7, 8 comes from 2. Square the 7, multiply together, and square the 2x. Same, opposite, always positive. Okay, so that's all you can do. Now, letter D. 2 and 1024. I don't recognize these. Well, I don't recognize them because, guess what? I can pull out a 2. There's a GCF. So it leaves me with x to the third plus 512. So 512, that was 8 to the third. So I have a 2 out here, and then my little part, big part. I got x and 8. Square the x. Multiply x and 8 together. That 2 just sits there. And then 64. Same, opposite, always positive. All right, letter E, I really don't recognize these numbers and also those extra x's, but that's because both of these things divide by 2x. So I pull out a GCF of 2x, which leaves me with 8x to the third plus 27. So 2x just sits there. Binomial, trinomial. I got a 2x and a 3. Square the 2x, this 2x. So 4x squared, multiply together, 6x, square the 3. Same, opposite, always positive. Okay, so completely factored.